Hello everyone, I'm Ashok. Welcome to the fourth module, which is hypothesis testing, as a part of your course Statistics for Data Science. So you made it till this is great. So you're following, hopefully also practicing and understood all the concepts from the previous module. And hypothesis testing is a very important topic. This is used in almost all the research to prove or disprove a phenomena. So let's discuss about hypothesis testing um, as required for the data science. Okay, so um, we'll start with what is hypothesis. Hypothesis is a term, is a statement we start with to prove or disprove a phenomenon. That's high level. So uh, something like, let's say, there is no life. There is no life beyond Earth. Do you believe that? Well, most of the scientific community believes there is absolutely 99.999% chance that there is life beyond Earth. So this statement is, of course, not correct. But if you want to do it statistically, so I'm going to define this as your hypothesis, or more precisely, null hypothesis. We put it as H naught, or null hypothesis. And this is a kind of assumption or a statement we start with, and your entire research is to disprove it, or if you fail to disprove, then the statement stands. Okay, and when you have a null hypothesis, we also have alternate hypothesis. We can have several alternate hypotheses. For this scope of this video, I'm only considering one alternate hypothesis, which I say H alpha or HA, and that is opposite of what is null hypothesis. There is life beyond Earth. Okay, so this is called as setting up your hypothesis. Before you want to do any research or prove or disprove phenomena, we set up the hypothesis. In our case, H null is there is no life beyond Earth, and H alternative is there is life beyond Earth. Alternate is always opposite to the null hypothesis. We'll get back to the slide and see what they have. Okay, they're explaining that. And there's a previous one. All of your so I will leave this code in the description itself, so that you can download and practice it by yourself. So I'm going to continue in the same sheet. So I call this as hypothesis testing. Okay, and I'm going to take a simple example to explain you what is hypothesis testing. So let's take average marriage age. Okay, so in India, the average marriage age was about 27, 28. Now it's shifting towards 30. It's about 30 now. So I want to statistically prove or disprove. In this case, I want to prove that the marriage age is 30. So I'll start with a null hypothesis. My null hypothesis is marriage age. So I should be very specific. Whose marriage age? So I would say marriage age of male in India. So is 30. And my alternate hypothesis automatically will become marriage age of male in India is not 30. So this becomes my hypothesis setup. Okay, so you could observe that, okay, the 30 is actually called as hypothesized mean. 30 here, 30 is hypothesized mean in this case, in this research. So what is 30? That's what I want to prove. I want to prove or disprove that 30 is the marriage age of a male in India. Okay, and 30 is called as hypothesized mean or an assumed mean, which I want to compare the distribution. You can see that null hypothesis is comparing a distribution to a single value, is comparing it. In this case, it is 30. So I'm going to say marriage age in India is equal to, well, ideally you need to collect this data from different channels. One of the best channel to collect this data is Facebook or any social media. So Facebook, you can simply run a poll saying what is a marriage age, what age you got married. So you have to actually take a sampling from a married male, because this only applicable is the marriage age. So when did you get married? So it's only married people in India. You basically put the filtering in Facebook poll saying India, male, unmarried. Accordingly, it will show to the only people, and it will be, of course, random sample, because Facebook shows it many different people. And well, if hoping that everyone is using Facebook nowadays, it is more or less true. So we could take that as a broad India population. Okay, and marriage age, after the survey is done, of course you need to incentivize the survey. So if you want to do it, you say that, give me your marriage age, anonymous of course, and you will be getting a PDF or document, or a book, PDF book, which says how to live a happy married life. And trust me, people always fall for that, and they might take your survey. So I'm just going to guess. So let's say 32, 28, 29, 31, okay, 29, 31, 34, 33, 32, 35, 30, 35 again. So 32. Okay. So, you might get 1,000, 2,000 data. So I'm just taking few data for explaining the things. All right. So this is the marriage age of India, which supposedly you got from Facebook, random selection, random sampling. And let's say it is 1,000 records. I have only a few here. So in hypothesis testing, so there are different tests. For this, we should be going for what we call it as one sample t test. One sample t test. One sample t test. In one sample t test, we compare one sample distribution, which is a marriage age here, with an hypothesized mean, which is 30. Okay. So how do you do that? Well, we have t-test, a module, which is actually a statistical module. We can also do it manually. We have t formula. I'll explain that as well. But we have Python stats. So we can simply say stats.t-test one sample. So by pressing a tab, you can retrieve all the functions or modules in Jupyter. So that's what I'm doing. So this is one. If you're trying to copy from my video, just make sure that this is not L, this is one. Most people make that mistake. It's one sample, t test underscore one sample. I'm going to pass my marriage age India and then pass 30 hypothesis mean. Run this. All right. So just before doing that, the t-test and whatever test I'm talking about, ANOVA test, analysis of variance, is parametric hypothesis testing methods. When you say parametric, we have to ensure that the data is normal. If the data is not normal, we cannot use the t-test. So first of all, we need to print, let's say, skewness of the data and the kurtosis. All right. So let's say stats.skew and marriage age in India. Copy this and say kurtosis and say, oh, okay, kurtosis, and oh, okay, slightly more kurtosis. So I'm gonna reduce this to 32 maybe. Okay, now it's okay. So I have skewness, which is almost near to 0. It's 0.04, which is wonderful. So your data distribution is perfectly symmetric. Okay, like perfectly symmetric. And skewness is also less than -1. So it is a little flatter. I can see that most of the data is around 30. So I'm going to make it little not flatter. There's a guy who married at 25. Poor guy. And 37. Lucky, isn't it? Marrying late is lucky. You have a lot of time for yourself. Okay, let me see. Now your skewness got little towards the negative side, and kurtosis is perfectly zero, which means you have a perfect distribution. Okay, in general terms, you cannot tweak the data. In fact, if you tweak the data, your research becomes invalid. Whatever data you get, you can of course remove the outliers, but other data you cannot remove certain part. Then it doesn't become a random sample. So you should be retaining all of your data which comes from the survey just by removing the outliers. So if you do a tweaking like what I'm doing, your research becomes invalid. Okay. Okay, so now I run the same test again. So from my test, I have two values. One is statistic, another one is p-value. Okay, statistic and p-value. P-value is nothing but probability value. So it's my test is my t-test is telling me that probability value or p-value, simply p-value, is equal to 17% or 0.17. It's like 17.05%. So which means that there is 17% chance that 30 is a marriage age, 17% probability or chance that the 30 is a marriage age of your distribution. Now the question is, with this data, will you be able to reject the null hypothesis or accept the null hypothesis? If you reject the null hypothesis, then we accept alternative. So null hypothesis says marriage age is 30. My test says there is 17% chance that 30 is your marriage age. Okay, here you need to know something. As a thumb rule, you can remember, if the p-value is less than 5%, then we reject null hypothesis. And this is kind of really thumb rule for you can remember it. And this is 95% confidence interval study. This is very common for most of the research, but if you're doing something related to medical or food, you might go for 99% confidence interval study where the p-value has to be less than 1% to reject the null hypothesis. But for you, for most of the statistics purpose, data science purpose, p-value less than 5%, you can reject the null hypothesis, which literally means if the probability value is less than 5%, if there is less than 5% chance that 30 is a marriage age, then you can reject the null hypothesis which says that 30 is marriage age. Makes sense, isn't it? Less than 5% chance is nothing. So we can reject it with 95% confidence. And that's why I called as 95% confidence interval study. Okay. So what you do here? Well, your p-value is not less than 5%. So your p-value is not less than 5%, which means you cannot reject the null hypothesis. We say we fail to reject null hypothesis, which means we accept null hypothesis. It might look weird. Hey, you only have 17% probability of 30 being marriage age. You are going to accept null hypothesis and say marriage age in male India is 30. Doesn't sound like a more logical conclusion. Yes, that's true. So doesn't really look nice because your research is weak actually because you're failed to reject the null hypothesis. If you successfully reject the null hypothesis, then you can strongly have a statement with 95% confidence that marriage age is not 30, which is an alternate hypothesis. Because you fail to reject null hypothesis, your research itself has become weak a bit and it doesn't have a strong statement. So we cannot reject the null hypothesis, so we accept it. Not happily, but that's the way the research is. So you cannot make a strong statement. Hope it makes sense. Okay. So this is one sample t-test, and it's really powerful t-test, powerful test to demonstrate a phenomena, to prove or disprove phenomena, equating it to a single value, which we call it as hypothesized mean. So what I'm trying to say is that the 30 is not, in this case, 30 is, of course, you cannot reject it. So 30 is, of course, a mean of this hypothesis, which means, yes, most of the Indians or Indians do get married at 30. We cannot reject that 30 is not the marriage age. We cannot reject the null hypothesis that 30 is marriage age. So if you look at the graphical way of doing this, what we have done here, Okay. Okay. All right. So let's say if you draw a histogram of all the people who have collected, let's say you collected for 1,000 people of the marriage ages, and you draw a histogram, and assuming that it is a nice normal distribution like this, and let's say the phenomena of the t is around just saying which set that is coming. T is positive means this is greater. Okay. So 30 is somewhere, let's say here. Okay. And this is 31, this is 32, and this is 29, and this is 28, and this is 27, and so on and so forth. Okay. So if you, so this is your entire data. So I want to find the probability of 30 being my marriage age. So when you want to say 30, so 30 actually can be taken as this region, which is between 29.5 and 30.5. The area between these two can be taken as 30. What's the probability generally? Probability P is actually desired outcome by total outcome. So if you say what's the probability of getting a head in a coin toss? So you say 50% because you're looking at head as one desired outcome. Total outcomes is head or tail, which is 2. 1 by 2 is 50%. It's simple. So of course, it's again high school mathematics. Hope you remember that. So in this case, let's say this area is what actually is 30, representing 30, divided by total area, which is the entire area of this curve. So I'm just gonna write it down with the red color, for example. So total area, which is this entire area. So we got a value of 17% approx, which is representing this area is 17% of the total area. And that is your probability value in the t-test. So it's so easy that your module t-test, one sample t-test is giving you the probability value straight away by calculating it from the way I showed you graphically. But what if you don't have this kind of tools and probability values? Traditionally, people used to follow t-value. So the statistic given over here is actually a t-value. As a data scientist or data science professionals, whatever I'm going to tell right now is not really required for you, because it's very simple for you to just look at the p-value less than 5%. We reject the null hypothesis. If not, we fail to reject null hypothesis, so we accept null hypothesis. But just to know the background, what is the statistic? So statistics, as you know from our previous discussion, is a parameter, is a summary of a sample variable. Okay, so this is a t-value actually. So t-value in our case is t-value in our case is actually 1.47. So you could also reject the null hypothesis if the t-value is okay. So if the t-value is greater than t critical, we can reject null hypothesis. It is very similar to what we have discussed before. If p-value is less than 5%, we reject null hypothesis. In this case, we can simply say less than 5% reject null hypothesis, no further questions. But here, we only have t-value. We need to also find t-critical. How do you find t-critical? Well, t-critical is found by looking at the table. So you don't have to calculate the t-critical. You simply, so I'm going to Google for t-critical table. So t-critical table, I can take any one of this. Let's say this is t-critical. I'm going to open it up as an image. So if you look at here, you have different t-critical values of different significance. So I'm looking at this alpha is equal to 0.05 because we know we are looking at 95% confidence interval, which means 5% alpha, 5. So this is the test. If you're looking for 10% confidence interval or probability 10% come here, 90% confidence interval, and this is actually 99% confidence interval. which is probability is 0.01. So I'm looking at this, and these are the degrees of freedom, number of records you have. So we have, I don't know, 12 or something. So it's coming to 1.79. So from the table, I have found that the t value from the table, my t critical value, or simply TC, I'll just write it down to critical for your simple understanding, is actually 1.79. 1.79. For that, I need to know how many records, degrees of freedom you have. Roughly, let's say you have 12. Okay, I think it's about 1.78. So what is our principle? If t value is greater than t critical, then we reject. So hope you can see this, where you can reject null hypothesis. Is it true here? No, your t value is less than t critical, so we fail. So here t value is not less than t critical. Here t value is not present, so we fail to reject null hypothesis, so we accept null hypothesis. So the conclusion here is exactly same as the above, but there we have simply did with the p-value, which is easily we are obtaining from our Python stats module, scientific Python module. There are many other modules. It's easy to calculate with the tools. Even you have SPSS or many other R related packages. Simply calculate p-value, you can do it. But if you want to go with the traditional method, we go with finding the t critical from a lookup table. You have a lookup table over here, and then compare the t value which you're getting from the test here with that. If the t value is greater than t critical, then we reject the null hypothesis. If not, we fail to reject the null hypothesis. Okay, first time when you look at it, it looks a bit of twisting, but please look at the video one more time, and you should be able to understand it. It's not very complex, it's actually simple, but it requires a couple of revisions before you understand it. But once you get the logic of hypothesis testing, the further analysis or the further study of other hypothesis testing methods will be very easy. All right, so hope you like this video. In the next video, we're going to talk about two sample independent t-test, and that's going to be the next video. Like the video, please subscribe to the channel. Also click the notification button so that when I upload the next video, you will get a notification. Thanks for watching. I'll see you in the next video.